Assalamualaikum warahmatullahi wabarakatuh and very good day update to panels and those who is watching this video. I am Amirun from Faculty of Mechanical Engineering UiTM Shah Alam. Today, I would like to present about my final year project entitled Strength of Carbon Fibre Graphene Oxide Composite Material under supervision of Dr. Amalina Amir. This presentation consists of 5 outlines which are introduction, methodology, results, discussion and recommendation. Now, I would like to explain about the introduction of my project. Carbon fiber reinforced composite are displacing metal in a variety of mechanical applications with outstanding quality, including the aerospace and automobile industries because of their excellent ratios of stiffness to weight and strength to weight. Carbon fiber reinforced composite have excellent mechanical and thermal qualities, making them a suitable structural material. Carbon fiber composites are particularly ideal for aerospace and military application due to its ductility with low weight, high young modulus, and specific strength. Graphene oxide is a novel carbon material with two-dimensional structure and exceptional mechanical, electrical, and thermal properties. It has been established in recent years that adding graphene to a metric may boost the metric toughness and improve the interfacial characteristics of graphene-based composites. Moreover, multi-scale reinforced which combine fibers with graphene in the metric or the fiber surface can also improve the interface characteristic. For example, fatigue life of fiber reinforced composite. Researchers across the world are working to reduce car weight and develop low-cost manufacturing procedures for lightweight materials like carbon fiber reinforced plastic. By doing physical and mechanical studies on the carbon fiber graphene oxide plate, this case study will establish optimized thickness of carbon fiber graphene oxide composite material to fabricate car body. Next, I would like to present about the methodology of this project. First is the material preparation. Material needed including carbon fiber, VE resins, hardener, mold release wax, fly sheet, and graphene oxide solution. Next is the process of making graphene oxide powder. 10 ml of graphene oxide solution was cooked in an oven for around 12 hours at 60 degrees Celsius. After a 12-hour heating period, the graphene oxide solution will be hardened. To obtain fine powder, the hardened solution then smashed using plaster mortar. After the process, around 0.13 gram of graphene powder was obtained. After that is the preparation of carbon fiber composite reinforced with graphene oxide powder. First step is digital scale was used to weigh carbon fiber sheet in order to determine the exact amount of resin required to make the carbon fiber plate. The resin must have the same weight as the carbon fiber sheet. A few drops of hardener were then applied to the resin, and then the solution was well mixed. The plate foundation was made of glass. To make removing the carbon fiber plate simpler, mold release wax was put to the glass base. Then, using a paintbrush, apply the first layer of resin on the glass base. Place the first layer of the carbon fiber fabric on top of the resin. Rub the carbon fiber resin in a circular motion until it equally spread. Then after that, apply a second layer of resin to the carbon fiber cloth. Repeat the process until the carbon fiber fabric reaches the fourth layer. Please apply sheet on top of the fabric last layer to catch any extra resin. Allow 12 hours for the carbon to rest, and after that, remove the carbon plate from the glass base with care. 4 layers of carbon fibers make up the original prototype. The second was made up of 3 layers of carbon fiber fabrics. The third prototype was built using 4 layers of carbon fiber fabric and a 0 to 40 weight ratio of carbon fiber resin to carbon fiber fabric to resin. In the remaining 3 samples, mix the graphene oxide powder with the resin. Combining resin with graphene oxide powder yield 3 different results. In each of the 3 subsequent cases, 4 layers of carbon fiber fabrics are employed. The 4th sample was created using 0.02 gram of graphene oxide powder. The second with 0.04 gram of graphene oxide powder, and the final one is with 0.06 gram of graphene oxide powder. The carbon fiber plate manufacturing process is then repeated. After that, the sample must be tested using tensile strength test. To accommodate the length of the test sample, place the lower and upper clamps in their respective positions. The sample should now be placed between the tension clamps. From the highest clamps to the lower clamp, position the sample vertically. During the test, the alignment will guarantee that the specimen is not subjected to any side loading or bending. After fastening the extensometer, attach it to the length of the sample. While being tested, the material will be monitored and measured by the extensometer. To begin the tensile stress test, carefully separated the tensile clamp at constant speed. Testing was done at a constant head speed of 2 mm per minute. During tensile test, the sample will generally break in less than 5 minutes. In the middle of its length, the specimen will eventually deform. During this period, changes in the stress strain curve will develop. The tensile testing is officially complete when the specimen breaks. Remove the specimen piece from the tension clamps once the fracture has occurred. The material tensile strength, yield strength and ductility will be calculated then. Lastly, the final methodology is metallurgical microscope analysis. The method was carried out by extracting specimens from the composite that were approximately 10 mm times 10 mm times 2 mm in size and placing them in microscope holders. Adjust the microscope focus until the sample picture on the monitor screen is clear. Then take a clear picture of the substance. Start with 50 times magnification and work way up until the 500 magnification. And carry out the same procedure with the remaining 6 samples. Prior to and after the tensile testing, the composite was subjected to microscope analysis. The identification of several entities of composites such as coir, carbon fiber, epoxy and graphene were done prior to the test. Following the tensile test, the attention shift to fiber breaking and void creation. Now, I would like to share about the project result and discussion. The table shown is the calculated value stress, strain and young modulus obtained from the tensile test. Next one is the graph of stress over strain of the 6 samples. When a strain rate of 2 mm per minute was applied, a linear relationship between stress and strain was found. By examining the ultimate strain value, the tensile strength may be determined. The maximum stress and the final strength was inexorably linked. The peak value of stress from the stress strain curve may be used to calculate maximal stress. As a result, the tensile strength will be larger the higher the peak on the stress strain curve. According to the data, sample 5 has the highest tensile strength of 6.75 megapascal, while sample 2 has the lowest tensile strength of 3.117 megapascal. Sample 5 has 82% larger tensile strength compared to sample 1. Moreover, sample 1 has the highest strain value of 0.065, while sample 4 has the lowest, which is 0.046. Sample 5 shows the highest young modulus value, which is 1,07142.857 kilonewton per meter squared, while sample 1 has the least value of young modulus, which is 57092.308 kilonewton per meter squared. From the tensile test, it is shown that sample 5, which is 0.0464 gram of carbon oxide powder, shown the best composition with tensile strength of 0.757 megapascal, strength value of 0.063 and 107142.857 kilonewton meter per meter squared of young modulus value. From the microscope analysis, figure A, B and C shows the nanostructure of epoxy and the carbon fiber fabric. Meanwhile, figures D, E and F shows the nanostructure of carbon fiber fabric, graphene and epoxy combination that has been fabricated. The figures depicts carbon fibers in the shape of tiny rod-like formation. The carbon fibers layout within the composite is also seen in this photograph. The layered microstructure of graphene oxide may also be visible in the form of flakes on the carbon fibers in the figure D, E and F. After the tensile testing, the composite was placed through another microscope examination. The graphene oxide layer developed voids and cracks because of the tensile stresses created inside the composite. The existence of cavities and fractures in the graphene oxide layer can be shown in figure B, C, E and F. In those images, the coir fiber breakdown is also visible. Due to tensile straining of the composite, little amount of graphene oxide flakes can be visible on the fiber surface that spread in numerous directions. There is a distinct impression of fiber disorientation when the composite is under tensile load. Now, I would like to present about the recommendation for this project. The first one is to do more mechanical tests on the samples. A few more tests can be done, such as fatigue tests and fracture tests. By doing more tests on the samples, we will obtain more data and result from those tests, and then the result can be analyzed and studied so that we can justify and prove our finding. Next recommendation is to fabricate more samples for the experiment. Variety of samples with different composition will result in various results from the mechanical test. From that, we can determine the best composition for this carbon fiber graphene oxide sample. And lastly, do scanning electron analysis, which is SEM on the samples before and after the mechanical test. SEM magnification ranging from 20,000 to approximately 30,000 magnification. Spatial resolution of 50 to 100 nanometer. So the image result of sample surface will show clearer and detailed image. In conclusion, the composite's tensile strength was ranked in this order: sample 5, then followed by sample 6, then sample 3, followed by sample 4, then sample 1, and lastly sample 2. When the result, the tensile strength of the composite rose as the graphene content was raised. The synergistic effect, on the other hand, resulting in the sample 5 having very high tensile strength. As a result, the composite strength is determined by the quantity of graphene. Finally, before and after the tensile testing, microscopes studies were carried out. Coil fibers, epoxy, graphenes and carbon fibers were discovered. Microscope picture was used to show fiber breakings, fractures and void development. That's all for me. Thank you for lending me your ears.